Hi there, my name is Richard Stillman. I'm in General Chemistry 2, Section 1 with Doane University. My professor is Dr. Ken Capps. This presentation is about how nuclear bombs work. All right, now without further ado, I kind of want to first talk about nuclear fission. Um, Fission happens when the release of energy from the nucleus of atoms when they split. Usually it takes a type of radioactive element like uranium. Um, they need to split those atoms to get the release of energy. That release of energy is what creates high amounts of heat. Um, have enough of it, have enough of the nuclear chain reaction, and you're going to get a bomb. So what they decided back in 1942 when they were working with the atoms in preparation for the nuclear attacks in Japan in Hiroshima and Nagasaki. Uh, that was in 1945. What they did is they put a dense metal called a radioactive element called uranium 235. Now, uranium 235 is a little bit different than its sister brother called uranium 238. Pretty much the two elements or two radioisotopes were different from each other only by weight. Everything else was pretty much the same. And what they did is they found out that it was more unstable. Splitting using fission on or uranium 235 would cause the neutrons to break off about 3 neutrons, and it would hit other uranium 235 atoms, and then they would split off some neutrons, and they would the process would just keep going on an exponential level, creating just a massive amount of energy. Just one of the reactions wouldn't be enough, but when it compounded and sent off a bunch of uranium 235 atoms, you get crazy amounts of energy. So they put this uranium 235 in the end of the warhead. There was actually two different atom bombs. One used in Hiroshima was it was called the Little Boy, and it was about equal to about 15,000 tons of TNT. And what was a little bit different is in Nagasaki, they were testing multiple radioactive elements. They used plutonium in the Nagasaki bomb. Plutonium, let me look it up here. Plutonium 239. So it was similar. They actually said they called it a fat boy. The shape of the atom bomb was a little bit different. It was a very like stubby and thick, and that was equal to about 22,000 tons of. I want to say tons. It might be kilotons. Either way, it was a lot of TNT, equal to a lot of TNT, and it pretty much did some serious damage and knocked out, probably won us the war. So what I just to go a little bit further into it of what's actually happening in the chain reaction, the the nucleus, the reason why uranium was actually chosen, the nucleus of uranium 235 is very unstable. It's very easy to break apart. That's how you can get that multiple chain reaction. And it happens very quickly, about a millionth of a second. Additionally, with a uranium. Uranium actually, we know it's a dense metal element. It was actually a material that came from a supernova that happened about 4.6 billion years ago. And this is it's very rare as far as all the elements in the Earth, and it's very protected. And there's a whole process that comes to get enriched uranium, which is enriched uranium-235, which is actually used for the nuclear bombs. That process, they basically they mine uranium ore, and uranium ore, it can do multiple things, not just for nuclear bombs. It can generate electricity, and some other stuff. But that the uranium mining, it goes through a process called in situ leaching. They basically drill in the rock, and they pump out a solution. It basically pumps out this dry yellow powder called yellow cake. And if you saw it in a pan, it kind of looks like cornbread all together, but it's this powder. And what they do is they break off through that enrichment process. They're basically deriving the less than 1% of the atoms that are actually uranium-235 atoms, the ones that are actually unstable. 238, not going to, all the other atoms, they're not going to do the process and release all the energy and stuff needed. So they have to enrich. And what else? I think that was it. Oh, lastly, with that enrichment process, they use a thing called a centrifuge. You might have heard of this. Basically, it takes all the, since the uranium-235 atoms are lighter, they're going to separate from the 238 atoms in the centrifuge, and then it gets feeded off. And then they dump out all the 238, and the 235 gets separated, and then they can use that. But there is some waste. There's some depleted U-235, and that gets put in something else where they can use that for building ceramic fuel pellets, makes cookware and stuff like that. So it's pretty crazy process. And just all of this just really interests me. I had I was fortunate enough to actually visit the A Dome, which is the place where the bomb went off, and realized why we targeted that. It was the biggest Japan military base, and it was actually where they were where most of their general officers were located. So I always thought that was pretty cool. But now I know the actual science behind what went on in that process. So anyway, thanks for listening to my presentation. Hopefully I explained everything appropriately. Thanks.